We've talked about cannabinoids protecting the brain on here, but we haven't talked about the biggest and most mysterious function of all, retrograde transmission. I'm Lex Pelger. I do canna education for CV Sciences, and this is a new account, so you can help us out with a follow. And as always, ask me anything. To explain retrograde transmission and the endocannabinoids, we have to go back not one, but two giant scientific debates. The funny part is that these two great scientific debates, complete with severed friendships and charges of imbecility against opponents, ended how most scientific debates end. The first one was between two neuroanatomists, the greatest of their day, who shared the Nobel Prize for how the brain works. Despite the fact that Golgi and his opponent Ramon y Cajal had diametrically opposed views of how the brain works. Golgi was even a little bit snarky about it in his Nobel Prize acceptance speech when his rival was sitting right there. But Golgi believed that the brain was one undifferentiated mass, that it was not a series of cells, that it was one big piece of tissue, a 3-pound piece of flesh that handled all of our processing needs. While Ramon y Cajal delicately traced the tendril of the brain and decided that it was actually a series of individual cells, of neurons that communicated across the thin gaps in between them. As we all know, it was actually Ramon y Cajal who came up on top on that scientific debate. Now we believe the brain is made up of individual neurons. But we find out later Golgi wasn't wrong. It turns out that there are gap junctions. There are connections in between neurons that allow things like electrically charged ions to cross directly across them. So even though we thought for the longest time that it was just Ramon y Cajal and the neuronal doctrine that was correct, it turns out Golgi was correct as well. And that's what you usually see in scientific debates. The answer usually ends as both. The next great scientific debate was even more acrimonious. It was called the soup versus spark debate. And the idea was, how are these neurons communicating between them? Is it a spark? Because you could detect electricity in the brain. Is this how these neurons were communicating? Or was it soup? Was it neurotransmitters going in between these neurons? And the great debate was, is it the electricity or the neurotransmitters that were allowing these neurons to communicate? And even though now we believe it's neurotransmitters in between the neurons that do the communicating, in between those little synaptic clefts between them, we also know that the neurons themselves use electricity within the neuron to communicate. And so it turns out that, again, for the soup versus spark debate, the brain runs both on soup neurotransmitters and on spark electricity. So finally, with these debates settled, the dogma of the day became, you'd have a neuron here, and it would use its mouth, also known as axons, to pass on its signal to the dendrites, to the ears of the next neuron. And that information always went in this direction. You would have electricity within this neuron saying, yes, fire, pass on our signal. And then in between it would release neurotransmitters to go to the next neuron and say, yes, fire, pass on your signal. And it always went this way across the synaptic cleft. The neurotransmitters were going downstream. And the crazy thing that we've realized is, despite that being the dogma for such a long time, the endocannabinoids, along with just nitric oxide, the gas that is in the air, those are the only retrograde molecules that we know. That means when this neuron here is firing and sending its signals using neurotransmitters to this neuron down here, this one has the ability to use endocannabinoids to go back up against the flow of information across the synaptic cleft and tell this neuron, we get it, calm down your firing, don't overstimulate us. So this would be a positive feedback loop, this would be a negative feedback loop, and that's what can make the endocannabinoids so effective, is they are a way for the brain to calm down its firing. It's probably the reason you see CBD being so effective for epilepsy at really high levels of CBD, and I suspect why it's helpful for the brain in general is that it is a negative feedback loop that allows the brain to calm itself. So hopefully you found this as fascinating as I did. The ability of retrograde transmission to the endocannabinoids to protect our brain is probably one of the reasons that they've been such a stalwart of human health throughout history.